Hello everyone, welcome back to another video. So today we'll discuss weekly contest 397, and I was able to solve first three problems, but fourth problem was somewhat, I would not say tricky, but we'll discuss that at the last. Not complete editorial, but approach for it. So first let's start with first question. So in first question we are given two permutations of same string, and we have to find sum of absolute differences between index of occurrence of each character, and it is guaranteed that any character occurs at most once in both the strings, and if it occurs in S, it will also occur in T because they are a permutation. So let's see first example. In this case S is ABC, T is BAC. So if you calculate the difference between index of A is 1, difference between index of B is 1, and difference between index of C is 0. So 1 plus 1 plus 0 is 2. So answer here is 2. Similarly, you can calculate this. Now you can solve this in n square, but I just created two maps and stored the index and iterated over all characters from A to Z and added absolute difference of both the indexes. So this was first question, pretty simple, as acceptance rate you can see. Now let's move to second question. So in this question we are given an array, and we can fix a starting position and jump to I plus k until we reach end of array, such that I plus k does not exist, or I plus k is greater than equal to n if we are working with zero based indexing. So in each so we have to choose and start position and find all the, after making x number of jumps such that I plus xk is less than n, we have to find sum of all those elements which were present in those jumps, and out of all possible combinations we have to find the one which gives maximum total sum of energy, and we have to print that value. For example, in first case 5 to minus 1 minus 5 and 1. If we start from this 5, I can jump this to minus 5 this, and after that array ends, so answer here is 0. If I start from this 2, I can jump to this 1, so answer here is 3. If I start from this minus 10, I don't have any jumps because it will end in array, so here is minus 10. Similarly minus 5 and 1, so maximum answer here was 3. That's why output is here is 3. Similarly in this case, if we start from minus 2, after 2 jumps it will go to minus 1, so minus 2 plus minus 1 minus 3. If we start from minus 3, then it will end at the array, so minus 3 itself, and for minus 1 again minus 1 itself. So maximum of all those possible combinations is minus 1. That's why answer here is minus 1. So if I start from I plus 1, what will be my answer? Answer would be something like a of I plus answer when I start from I plus k. This kind of transition was in this question expected, so you can do this with pre-computation, or you can write a recursive 1D DP, but from just iterating from last to start seems a pretty simple solution. So if I am at position dp of I, at ith position, dp of I would be a of I plus dp of I plus k, and this is a pretty standard skipping step type of dp problem. You must have seen if you have practiced. some standard problems in DP. So let's just see the code. First I declare DP and DP of n minus 1 with a of n minus 1, and I also declare a max variable which is initialized with DP of n minus 1, because that can be one of my answers, the last element, and k is always positive, so you don't need to worry of infinite jumps at last position. And I'm iterating from n minus 2 to 0, first making dp of I equal to a of I, and if I plus k is less than n, I will just add dp of I plus k in dp of I and take max of dp of I and finally return mx. So this was second question. Let's move to third. I don't think we need to spend more time on second question because it is a standard DP problem. Now this is also a standard DP problem, but you have to make some changes and find some observations. So in this question we are given an matrix of m cross n, and we can move to from a cell in the matrix to any other cell, that is either to bottom or to the right, and score of that move from cell with, so if the current cell is c1 and the switched cell is c2, the score of such move is c2 minus c1. Now you have to find, we can start from any cell and we have to make at least one move, and we have to return maximum total score we can achieve. So now this is written there that it should not be, it is not necessarily adjacent. So let's say I have this matrix 5 4 6. So if I start from this, I can move to this 2 or this 3 or this 5. So it is not necessary that to move adjacent to bottom, you can move any cell in the bottom. Now observation here is that if I say from 1 to 5 I directly jump, what will be my score? It will be 5 minus 1. Now another possible way to go to 5 can be 1 to 3 and 3 to 5. So with that possibility, what my score can be? First 3 minus 1 plus 5 minus 3. Now if you see here, that 3 is, the contribution of 3 is getting cancelled, because it is in one of the moves it is a switched cell, in one of the moves it is current cell. So switched cell will be add the contribution of 3, and current cell move will remove the contribution of 3. Now if you see like this zigzag type of transition also, what I if I move directly from 1 to 5, I cannot move directly, but let's consider I can move this directly. So answer here would be 5 minus 1. But if I say something like 2 minus 1 first, then 3 minus 2, then 4 minus 3, and then 5 minus 4. Now everything other than 1 and 5 will get cancelled. So answer here would be 5 minus 1. So we don't need to worry about this condition. We have that moving to adjacent cell, not necessary condition. We have to consider that it is moving to adjacent itself, because eventually if it is reaching some cell, the direct cost and via adjacent cells cost will be equal. So this was first observation. Now second observation here is somewhat related to cadence algorithm. Let's say I'm making what I can say, I'm making a transition from 3 to 5. And after this, let's say I am making a transition from 5 to 1. Now while moving 3 to 5, what was my cost? 5 minus 3, which is 2. But after this, I don't need to add this in my cost because it is a negative number. So in this case, this is a DP question. You must have understand where I'm storing DP of ij as score till I maximum score if I'm starting from I and j. So it can go either to DP of I plus 1 comma j, or it can go to DP of I and j plus 1. Now if the DP of I comma j plus 1 or I plus 1 comma j is itself negative, why should we add it? We shouldn't add it. That's what in cadence algorithm we do. If the current sum is less than equal to 0, we just make current sum equal to 0. So that also was some variation in this question which I thought was useful. And via these two observations we can solve this question. So let's see the code first. Let's see the code. So I'm declared n and n is rows, m is columns. This is my way of nomenclature, I would say. N is rows and m is columns, but they give m into n, so remember that. And then I have declared a dp and mx with int in. Now first of all, I am initializing the last row and last column of my dp table, because there is only one option for those that last row and last column. So for last column to go bottom and for last row to go right, it cannot go up and this cannot go left. So for that I'm iterating over first I'm iterating over last column, and if I can go to I plus 1, what will be my answer? A of I plus 1 m minus 1 minus a of I m minus 1 plus dp of I plus 1 m minus 1, and then taking max of it. Now while going forward, if dp of I comma m minus 1 is negative, why should I consider going this? As you have understood in that cadence algorithm variation, in cadence algorithm what we do, if my sum is 0, why should I take this as a part of my sub array? So if the sum till this is negative, I don't need to consider it. I can just only need to consider this movement till this. So if it is less than equal to 0, I will just update it with 0. Same for last row, and then I am iterating from this cell. So the last cell which is not in the last column and last row. So in this case I have two options: to go right, to go bottom, and take max of both of them and update my current max. And this condition again, if dp of ij is negative, I don't need to go there for next previous steps. So after updating this would be used in some next steps. That's why I'm updating this again and again every time. And this was third question. This is also a standard question. I solved this pretty fast, but I had 3 wrong submissions. That's why my rank is so bad today, and I should have solved D. So let's see, let me explain D, and I can give you a hint. I kind of solved this question, but I couldn't backtrack. I had to print a vector here and I was facing issues for backtracking that vector. So in this question we are given an nums, which is a permutation of the n minus 1 n elements from 0 to n minus 1, and we have to find score of any permutation such that the score is defined as this formula, where perm of 0 is score is absolute of permutation of 0 minus nums of permutation of 1 plus permutation of 1 minus nums of permutation of 2 up to n permutation of n minus 1 minus nums of permutation of 0. So you can see pattern here that permutation of 0 minus nums of permutation of I plus 1 nums, so permutation of I minus nums of permutation of I plus 1. I have to keep adding it up to till I is n minus 1, and then I plus 1 would be n, then we have to take mod of that and subtract nums of permutation of 0. Now basically what we have to do, we have to generate all possible permutations and find minimum answer. Now how can you do that? So brute force solution will be n factorial by fixing one state. By fixing one element, I have for first I have n options, for second I have n minus 1 options up to last, so this comes out to be n factorial. Now if you have solved traveling salesman problem, this is a standard DP problem which can be solved with bit masking and DP on bit masking. So I solved this, I was getting correct answer, I would say, means I was getting what is minimum cost, minimum score for all possible permutations, but I struggled backtracking I struggled in getting that vector, getting that permutation, and for getting that permutation we have to backtrack some answer. So I would say if you want to solve this question, I would suggest you understand this TSP problem. And when you use bit masking, when the order of elements is important, as you can see, a permutation, the order of elements is important because whatever operations we are doing here, the order is important. Similarly in TSP also order is important. It is a graph problem, so cost of each edge is added in final answer. That's why the order in TSP is also important. So if you want to understand this question, first understand this TSP, and after that you will be able to solve it if you know backtracking. So what mistake I did here is I couldn't write a cleaner code, I would say, and a better approach would have been I just saw solutions of some people in the rank list, and they have written a very clean code, and better approach for backtracking would be just store option at with DP. So create another 3D vector with option and store that next element in that option vector, and while backtracking a normal for loop, similar to when we try to find the minimum path in Dijkstra using just while loop. If we have next element stored, parent stored in each parent stored, as we store parent for each node in Dijkstra, we have to store next option for each transition, and via that you can solve this. You can also retrieve this vector pretty easily. So I will try to solve it, but this was the main idea, this DP with bit masking and relation with TSP problem. So I think that's it from my side. and thank you for watching.